Hello. Today we are going to solve one numerical question of AIME paper 1 2020. In this question we are given that a club consisting of 11 men and 12 women. There are 11 men and 12 women, and there needs to choose a committee from among its members so that the number of women on the committee is one more than the number of men in that committee. And the committee could have as few as one member, as many as 23 members. And here n be the number of such committees, number of such committees that can be formed, and we need to find the sum of prime numbers which divide capital N. So we case work on the amount of men on the committee. If there are no men in the committee, then there are 12C1 ways to pick the women on the committee. If there are no men, then there are 12C1 ways to pick women on the committee. Okay, it is pretty much easy to understand. Now, for a total of 11C0 multiplied by 12C1. Okay, so this is the total number of ways in which no men and only one female can be choose. Okay, now notice that 11C0 is equals to 11C11, as we know that NCK can be written as NCN minus K. Okay, therefore uh, here we can say that where no men are picked can be grouped with the case where all men are picked. No men are picked. This case can be grouped with the case where all men are picked. Okay. Now, when all men are picked, all females must also be picked, because by the question we know that the number of women on the committee is one more than the number of men. So, if in the committee there are 11 men, then there must be 12 women, that is all women. So, we can write that if 11 men are chosen, then there must be 12 women in that committee by the question. Okay, so these cases can be combined to these cases can be combined to 11C0 multiplied by 12C1 plus 11C11 multiplied by 12C12. And as we know that 11C11 can be written as 11C0, so we take 11C0 as common. Therefore, we have in bracket 12C1 plus 12C12. Okay. Now, as we know that 12C12 is nothing but 12C11, sorry, 12C12 is nothing but 12C0. 12C12 is equals to 12C0, and as we know that NCK plus NCK plus 1 is equals to N minus 1 CK plus 1. Okay, therefore we can write that 12C0 plus 12C1 is equals to 13C1. Okay, therefore we can say that this case is nothing but 11C0 multiplied by 13C1. Okay, as 12C12 is 12C0, and here we have 12 plus 12C1. So comparing these two cases, we have 13C1. So this case is written as 11C0 multiplied by 13C1. Similarly, proceeding in this way, we can write the other cases also. The other cases are 11C1 multiplied by 13C2 plus 11C2 multiplied by 13C3 plus 11C3 multiplied by 13C4, and lastly 11C4 multiplied by 13C5. Sorry, there is another one case, that is 11C5 multiplied by 13C6. Okay, now from these two cases we have the multiple 13 only. Here we have 13, and in the next one we have 11 multiplied by 13 factorial divided by 2 factorial multiplied by 11 factorial. And from the next case we have 11 factorial divided by 2 factorial multiplied by 9 factorial, and here we have 13 factorial divided by 3 factorial and 10 factorial, and so on and so forth. So after solving this, we get 11 multiplied by 13 multiplied by 12 divided by 12 divided by 2, and after simplification we have 13 multiplied by 11 multiplied by 6. Okay, and here we already have 13, and after simplification this term we have 11 multiplied by 5 multiplied by 13 multiplied by 2 multiplied by 11, and so on and so forth. So from the first case and from the first two cases and from the others, the common factor is 13. So we take 13 as common, and we have 1 here, and here we get 66. And from the rest we also have 121 as a factor. So we have here 5 multiplied by 2, and here we get 75, and from there, and from the second last one we get 270, and from the last one we get 504. You can check this by elaborate expansion. Okay, so from the first two we get 67, and here we have 121, and after add all these things we get uh, and then multiplied by 121, we get 103,939. Okay, and after adding this we get 104,006. Here 13 is already a prime factor, and here we all get 2 as a prime factor. Then we have 52,003, and from here we also get another prime factor, that is 7. Okay, multiplied by 7429, and after factorizing 7429 we get 3 prime factors, that is 17, 19, and 23. Therefore, adding all these prime factors, we get 81, and this is the answer. Okay, so as we can see, we need to find the sum of the prime numbers that divides n, or the sum of the prime factors of the number capital N. So the sum is 81 here. So that's all for today. Thank you very much.